Hey guys and girls, welcome back to question number 20 for our ACT quiz. We are interested in a situation where a flagpole casts a 9 foot long shadow and the ground's level and the flagpole is perfectly vertical. And we don't know how high the top of the whole flagpole is. And then there's a fence post that we do know how tall it is, and that fence post is 4 feet tall, and it casts a 2.4 foot shadow. So you might realize, oh goodness, one looks like a smaller version of the other. And when we see that, we should immediately be thinking about similar figures. So similitude, similar figures. So this is what we are looking to work with is similar figures. So rather than sketch this out immediately, I want to take a short little detour with you and talk about something that doesn't necessarily seem all that related at the outset, and actually take a look at the graph of y equals 5/3 of x, or as we remembered in class, that's approximately 1.67 times x. So that is approximately 1.67 times x. And now let's think about where this line is going to go. So if I come over here and x is 0, then y also has to be 0. So 0, 0 has to lie on this line. And then if x is 3, then y would have to be 5. And there's a second point on the line, so 0, 0, and 3, 5. And then I could have maybe another point right here, 1.5, 3.5, 2.5, 2.5. So 2.5 right there. So 5 halves, 3 halves, 5 halves. And let's just draw that line through all 3 of these points. And let's drop a couple of perpendicular lines from here to here. This is 1.5. Then here to here, this is 3. And I'm going to give myself some point names. So we're going to call this point A, B, C, D, E. And we know that because we dropped these perpendicular, these are right angles. So we've got right angles, and triangle ABC is a right triangle, and ADE is also a right triangle. Well, how did this all come to be? How could I maybe generate triangle ADE from triangle ABC? Well, if I started with point B and I pushed it out to go twice as far, point B would land as point D. And if I went and I pushed in the direction of line AC, I pushed this out to be twice as far, I would land with point C sitting on top of point E. And let's think about what this means. That means that triangle ADE is obtained by dilating triangle ABC with center of dilation at A and scale factor two. So triangle ADE is obtained by dilating triangle ABC with center dilation at A and a scale factor of 2. So let's also think about the length of these two red sides of the triangle that we dropped from points B and D to the x-axis perpendicularly to the x-axis. Well, when we shoved points D and E out by a scale factor of 2 in the same direction, what happened to the vertical side of the triangle? Well, when we doubled the other two sides, we ended up having to double the long side of the vertical side of the triangle. So BC is 1/2 of DE, or DE is twice BC, because of the scale factor of 2 that we use with this dilation. So that is what we also learned. So if there is a similarity transform and all of the three sides are twice as long, well, let's think about this. We've got the angle here and the angle here and the angle right here. That's just exactly the same angle. So that means that all of the angles in ABC so all of the angles in triangle ABC match the angles in triangle ADE. That means ABC, triangle ABC, is similar to triangle ADE. And what that would also tell us is that AB over AD equals the scale factor of the dilation, which is 2. And then we would know that BC over DE, AD, let me clean that up, AD over AB, the side of the bigger to the side of the smaller, the corresponding side, would be in ratio equal to the scale factor of the dilation, which is 2. And then I would know that AE to AC is also the scale factor, which is 2. And then BC is half of DE, so we would also know that DE to BC is equal to the scale factor, which is equal to 2. So what we would know is that corresponding parts of similar triangles are in proportion. Okay, that was a really, really important thing for us to understand about the situation that we have. So let's do something that is a really, really good idea on any question that asks about measurements in the real world, where they haven't given us a drawing to work with. Folks, when that happens on the ACT, it's going to be very important that you actually draw your own. You need to draw your own. So let's take a look at our flagpole situation. So we know that the flagpole is lit up by the sun, and it makes a shadow on the ground. And this shadow is 9 feet. And we don't know how tall the flagpole is, so we'll call that H. But we do know that this is a right angle here. And then we have a smaller version of this where we have a fence post. And the sun is back up over the fence post. And the fence post is also making a shadow. And because the sun is so far away, there would be no difference in these two angles. So there would be absolutely no difference in those two angles. And we also know that this is going to be a right angle. So when we know that two angles in two different triangles are equal, well, we could easily get the third triangle's angle as 180 minus the two that we know. So let's just mark that with what we actually know now. And we know that this is 4 feet, and this is 2.4 feet. So let's just write an equation of proportionality, which is going to say that basically the pole length to the shadow equals the post to its shadow. Because in these two cases, the pole corresponds to the post, and the shadow caused by the pole corresponds to the shadow caused by the fence post, the flagpole and fence post, respectively. So let's plug in the things that we don't know. Remember, we have defined H to be the unknown height of the flagpole. So what we would now have is H over 9 feet equals 4 feet over 2.4 feet. So H is equal to 4 feet times 9 feet over 2.4 feet. And then we would also say that that is 36 feet squared divided by 2.4 feet, which is 15 feet. So 15 feet. Right there would be the height of the flagpole. And if we take a look at it, 15 over 9 is equal to 4 over 2.4, which is, ironically, 5 over 3. It is 5/3. And that was the slope of the line that we actually started with. So, wow, so now we've seen a lot of things tied together. We have seen a line in the coordinate plane lead us to the idea of a dilation, lead us to the idea of similar triangles. We've talked about the dilation scale factor as the ratio of corresponding lengths in the similar triangles. and we used the idea that corresponding parts of similar triangles are in the same proportion. So that means the pole to its shadow is equal to the post divided by its shadow. And then when we were able to do that, we were able to use that information to write a true equation for what we had, solve it for h, and we got 15 feet, and we were on our merry way to the next problem. So that's all I've got for this question. Thanks for watching.